30-2s. Welcome to the last lesson in this course. You've made it almost. All right, let's finish out on a high note. Mutually exclusive events. Okay, what does it mean to be mutually exclusive? Well, let's just think about for a second that we've got two dice. So we're going to roll two dice. And I'm going to say to you, there's going to be two events. Let's call the first event getting a sum of 5. And let's call the second event getting a sum of 10. Can I roll two dice and get both of these things at the same time? Can I get a sum of 5 or a sum of 10 at the same time? Well, the answer is no. You're like, come on, man. Like, I'm either getting the sum of 5 or a sum of 10. I can't get both, right? Okay, so what does that mean? These things can't happen at the same time. This is known as mutually exclusive. If two events cannot occur at the same time, like getting a sum of 5 or a sum of 10, we call these things mutually exclusive. Okay? Or sometimes we'll be lazy and we're mathletes, so we'll call it just ME for short. Okay? So what does it mean to be mutually exclusive? Well, these are or statements. I'm going to get a 5 or a 10, a sum of 5 or a sum of 10. Remember what the word or in mathematics means. It's the union, and the operation is for us to simply add. Now, what happens if we had two events that weren't mutually exclusive, like the events of rolling doubles or a sum of 10? That can happen at the same time because I can roll two 5s and that's a sum of 10. So what we describe these as is not mutually exclusive. I'm just going to write not ME here. So this formula above won't work because we're going to have an overlap of the event that can happen for both scenarios. So what we're going to do here is we're going to take care of that intersection. So for not mutually exclusive, if you notice, it looks the same to begin, PA plus PB, but then what we're going to do is we're going to subtract out that intersection, the thing that happens that's in common for both events. Again, no need to memorize these. Everything you need in 30-2 is right here on your formula sheet. Okay, so it's right here. So the first one is mutually exclusive, and the second one is not mutually exclusive. There it is, my friends. There's all your formulae for this unit. Okay, let's go and play around with a few questions here. Oh, another way to represent these things is, of course, with a Venn diagram. So if two events are mutually exclusive, it means they have no overlap. Remember what we called that in another unit. We called those events disjoint. Right? They're mutually exclusive. They have no intersection. Whereas the second, we have some events in common, we say it's not mutually exclusive. Okay, now let's try some questions. In a class of 30 students, 10 are brunette, 15 are blonde, 5 are redheads. Determine the probability of a student being a brunette or blonde. Okay, and okay, for the sake of argument, let's say that you're one or the other. You can't be both, right? Not counting fancy dye jobs. So what do we got? The probability of being a brunette or a blonde. Well, since they're mutually exclusive, since I really can't be both, I'm going to say it's the probability of being a brunette plus the probability of being a blonde. Well, there are 10 brunettes in the class out of 30, and there are 15 blondes in the class out of 30. So what does that tell me? It tells me the probability is going to be 25 out of 30 which is also 5 out of 6. There it is. Okay, so mutually exclusive, not so bad. Number 2, using a standard deck of cards, what is the probability of drawing a king or an ace? Are these events mutually exclusive? Yeah, they're mutually exclusive. I can't pull one card and get a king and an ace at the same time, right? So they're mutually exclusive. So when I go to use my formula, the probability of getting a king or an ace is equal to the probability of king plus the probability of getting an ace. And there's 4 out of 52 ways to get a king. And there's 4 out of 52 ways to get an ace. And that's 8 out of 52, or 2 out of 13. So again, as soon as I know it's mutually exclusive, I know all I simply have to do is add these things together. It's easy. Let's try another question. Using a standard deck of cards, what is the probability of drawing a 7 or a heart? Are these mutually exclusive? No, these are not mutually exclusive. How am I going to justify that? Well, it's called the 7 of hearts, right? I can get the 7 of hearts. It can happen at the same time. So when I go to write out my formula, the probability of getting a 7 or a heart is the probability of getting a 7 plus the probability of getting a heart minus the probability of getting a 7 that is a heart. 7 and a heart. Okay, so what do we get? Well, the probability of getting a 7. Well, there's 4 sevens in the deck. There's how many hearts in the deck? 13 out of 52. But again, if I added those up, I'd be missing the fact that there's this 1 7 of hearts in the deck. So I need to make sure I subtract that event out. And so that'll be 16 over 52, which reduces to what? 8 over 26, which is 2 over 13, if I've done my math right, which I don't think I have. Uh, no, 4 over 13. See, I knew something looked wrong there. Too late at night tonight. There it is. Okay, so there, when it's not mutually exclusive, we're going to subtract out the intersection. In this case, the intersection is what's in common of both events, the 7 of hearts. All right, let's try a couple more here, friends. Another standard question to get on the diploma is to, in a numeric response, to label things 1 or 2 as mutually exclusive, not mutually exclusive. Okay, let's see. Rolling 2 dice and getting a total greater than 7 or a total less than 10. Okay, can I get a sum less than 7 or greater than 10 at the same time? No. So these are mutually exclusive. From a standard deck of cards, drawing a heart or a diamond. Well, I'm either a heart or a diamond. I can't be both. Mutually exclusive. From a standard deck of cards, drawing a jack or a spade. Well, that's not mutually exclusive. Well, if it's not, provide me an example why it's not. Well, it's called the jack of spades, right? It's both. Okay, so if it's not mutually exclusive, you should always be able to provide an example of why not. Okay, selecting marbles from 2 bags. Selecting a red marble from 1 bag and selecting a green marble from a second bag. Yeah, it's mutually exclusive. They've got nothing to do with each other, right? They're 2 separate bags. Okay, now looking at this Venn diagram I've got here, let's just look at the sets F and V. Okay, well, F and V, I would call F and V mutually exclusive. They're disjoint. So F and V are disjoint. I could also say S and V are disjoint. Okay, so again, when there's no intersection, we're disjoint. What's not disjoint? What's not mutually exclusive? Well, in this case, the sets F and S are not mutually exclusive because Set S is a subset of set F. They've got a huge intersection. Okay, so again, we just want to always be able to visualize these things as Venn diagrams as well. So set F and V and S and V are mutually exclusive. Okay, the next one here, well, what the heck is this? That's literally the definition of mutually exclusive. I'm just adding them together, right? Don't get any easier than that. Sure it does. Look at this one. I'm subtracting the intersection. That's the definition of not mutually exclusive. All right. Here's another Venn diagram. Well, as soon as I see that overlap there, not mutually exclusive. And let's try two more. In a class of 32 students, 17 play guitar, 10 play the drums, and 5 play nothing. Okay, well, what I want to do here is maybe draw a Venn diagram quickly. Here's the kids playing the guitar, here's the drums, and here's the kids doing nothing. How did I know they were going to be mutually exclusive? Because 17 plus 10 is 27, plus 5 is 32. There's everyone accounted for. These are mutually exclusive events. Okay? Now on the next one, it says of 50 McDonald's employees, 35 work the fry machine, 20 work the hamburger machine, and 10 make milkshakes. Well, what I want to notice is if I add these numbers up, I'm going to get 65 employees, but it says there's only 50. So what that means is there's an intersection here. There's an overlap of 15 somewhere, right? I guess there's 3 sets, isn't there? That's an ugly looking Venn diagram, but there's more people accounted for than there are employees, okay? So I know it's not mutually exclusive. Okay, let's try just a couple more and we are done. Okay, last 3. Given a standard deck of 52 cards, determine the probability of drawing a heart or a king. So again, heart or a club, I should say. So these probability heart union club are mutually exclusive. So it's the probability of a heart plus the probability of a club. Probability of getting a heart is 1 out of 4. Probability of getting a club, 1 out of 4. Well, guess what? That's a half. Okay, probability of getting a diamond or a king. Well, I can get a diamond, I can get a king, but I can definitely get both, can't I? So probability of getting a diamond, I'm just going to leave this as 13 out of 52. Probability of getting a king, 4 out of 52, but I can get the king of diamonds, 1 out of 52, which sounds like 16 out of 52, which is 8 over 26, which is 4 over 13. So not mutually exclusive. All right, one more just for practice. Probability of a heart or a face card. So this is definitely not mutually exclusive because I can have, oops, I started with the wrong one there. I can get a heart. I can get a face. I can get a heart and a face, right? So there's 13 hearts. There is 12 face cards, Jack, Queen, and King of each suit. But how many hearts are face cards? Well, the Jack, the Queen, the King of hearts. So what have we got left here then? 22 out of 52, which sounds like 11 out of 26. Okay, my friends, there it is, your last lesson. Mutually exclusive and not mutually exclusive.